Hello and welcome back to the HIV RNA Test Guide podcast, your trusted source for HIV information and resources. We're always on the lookout for breakthroughs in HIV treatment, and
Oh, absolutely.
today we're diving into something truly remarkable, a potential new treatment that could eliminate HIV from the brain.
It's exciting.
I know, it sounds almost too good to be true, right?
Well, it is exciting. You see, even with our current antiretroviral medications, HIV can still play hide and seek in the body, becoming dormant and evading treatment.
And as our listeners know, the brain is like HIV's ultimate fortress. You've got that blood-brain barrier acting as a tough bouncer, keeping most medications out.
Exactly. The blood-brain barrier is great at protecting the brain from harmful substances.
Right.
But it also makes it extremely difficult for medications to reach the virus hiding there.
So this new research tackles that challenge head-on.
It does. This NIMH-funded study focused on a drug called BLZ-945
Okay.
and its effect on SIV, that's simian immunodeficiency virus,
Yeah.
which is very similar to HIV in primates.
Okay, so BLZ-945, it sounds like a secret code. Break it down for us. How does this potential treatment actually work?
Think of it this way. Imagine BLZ-945 as a special agent, skillfully sneaking past the blood-brain barrier to target a specific type of immune cell called macrophages.
Macrophages, we've talked about those before on the podcast, right? They're part of the immune system, but they can also be tricked by HIV.
Precisely. Macrophages are supposed to be the good guys, helping to fight off infections, but HIV is sneaky. It can actually hijack these macrophages and use them to multiply and spread within the brain.
So even with antiretroviral treatment, HIV can be hanging out in these brain macrophages, making them a source of ongoing infection.
That's the challenge, and that's why this research is so groundbreaking.
Right.
It suggests we might be able to target those infected macrophages directly.
And BLZ-945 is the key to doing that.
It could be. BLZ-945 works by targeting a specific protein on the surface of macrophages called CSF1R.
Okay.
By blocking this protein, it's like cutting off the virus's lifeline.
So it's not just stopping those macrophages from multiplying. It's actually preventing them from becoming active and helping the virus.
Exactly. It's like disarming the macrophages that HIV has weaponized.
That's a pretty powerful image.
Yeah.
But how did they actually test this? We mentioned primates earlier.
Yes, the researchers studied rhesus macaques,
Okay.
a well-established model for HIV research. They gave them different doses of BLZ-945 or a placebo, and then used some advanced imaging techniques to see what was happening in the brain.
And what did they find? Did BLZ-945 actually work?
The results were incredibly encouraging. They found that BLZ-945 significantly reduced both macrophage levels and SID levels in the brains of the primates. It was a direct correlation.
Wow.
Fewer macrophages, less virus.
It's pretty amazing. But I imagine you're also thinking about the potential downsides.
Yeah, of course.
Targeting something as important as the immune system.
Right.
There have to be some concerns, right?
Of course, safety is paramount. And anytime you're dealing with the brain, you have to be extra cautious.
Right.
So one of the first questions researchers asked was, what impact does BLZ-945 have on other vital brain cells?
Yeah.
Could it cause collateral damage?
What did they find? Our listeners are probably holding their breath right now.
Well, take a deep breath. The study found that BLZ-945 didn't harm other important brain cells like microglia,
Okay.
which are essential for healthy brain function.
So it seems like they've managed to target those problematic macrophages without harming the rest of the brain. That's a big win, right?
It is. It's a delicate balance, but the results suggest that BLZ-945 can work with a remarkable degree of precision.
But reducing the number of macrophages in the brain, I'm sure there are still questions about potential long-term effects.
Sure.
Macrophages play an important role in the body's defense system, even in the brain, right?
That's a valid concern.
Yeah.
Macrophages aren't just about fighting off invaders. They also help clear out debris and support overall brain health.
Yeah.
So researchers will need to monitor that closely as the research moves forward.
I imagine dosing is going to be a key factor there, finding that sweet spot where you're effectively targeting the virus without depleting macrophages to a dangerous level.
Exactly. It's all about achieving a balance, and that's something they'll be looking at carefully as they move towards human trials.
Okay, so targeting macrophages, sneaking past the blood-brain barrier, potentially eliminating HIV from the brain. This is all sounding pretty revolutionary. What are some of the other exciting outcomes from the study? Anything else that really jumped out at you?
One of the most promising findings was that BLZ-945 seems to boost the immune system's ability to fight SIV in the brain.
Wait, so not only is it reducing the virus's ability to spread, but it's also helping the body's natural defenses fight back. That's a powerful 1-2 punch.
It is. It suggests that BLZ-945 might be doing more than just suppressing the virus. It could be helping the body actually clear it out.
That's incredible. And for our listeners who are dealing with the cognitive effects of HIV, this next part is particularly relevant.
Sure.
The study also looked at neuroinflammation, right?
Yes, and they found that the primates treated with BLZ-945 showed reduced neuroinflammation.
Oh, okay.
This is really important because chronic inflammation in the brain can have a significant impact on cognitive function, mood, and overall well-being.
So potentially fewer macrophages, less virus, reduced inflammation. Are we seeing a pattern here? It sounds like BLZ-945 could be a game changer for people living with HIV, especially when it comes to protecting the brain.
It's definitely a step in the right direction, and there's one more finding that I think you'll find particularly interesting.
Okay.
The study showed that BLZ-945 didn't seem to affect SIV levels in the blood.
So it's specifically targeting the virus in the brain, not throughout the whole body. That's a pretty precise approach, and it highlights just how challenging it's been to reach the virus in the brain.
Exactly. This really speaks to the potential of BLZ-945 to address a problem that has stumped researchers for decades.
Okay, this is all incredibly promising, but of course, with any new treatment, we have to talk about safety concerns.
Right.
Were there any red flags that popped up in the study?
Well, some medications in the same class as BLZ-945, they're called CSF1R inhibitors,
Okay.
have been linked to liver damage in some cases. However, in this study, they didn't find any evidence of liver damage in the animals treated with BLZ-945 at the doses they used.
That's reassuring to hear. So they're definitely keeping a close eye on potential side effects, and at least in this study, there weren't any major concerns at the therapeutic doses. But I imagine there's still a lot more research to be done before BLZ-945 is available to people living with HIV.
Absolutely. This is just the beginning. We need more research, including human trials, to fully understand the long-term safety and effectiveness of BLZ-945. It's important to be cautiously optimistic.
Cautiously optimistic. I think that's a good mantra for all of us when it comes to new HIV treatments.
Yes.
But even with that caveat, this research is incredibly exciting. The potential to actually eliminate HIV from the brain, it's a game changer. And before we go any further, I want to take a moment to acknowledge the incredible work of the scientists involved in this study.
Okay.
Their dedication and innovation are truly paving the way for a brighter future for people living with HIV.
Absolutely. It's a testament to their tireless efforts and their commitment to finding solutions that could transform the lives of millions of people.
So we've covered a lot of ground in this first part of our deep dive. We've talked about the mechanics of this potential new treatment, the encouraging results from the primate study, and some of the safety considerations. But there's still so much more to explore. What are some of the bigger questions that this research raises, the kind of things our listeners might be wondering about?
This research opens up a whole new frontier in HIV treatment. We've been so focused on suppressing the virus, but now we're talking about potentially eradicating it from a place where it was once thought to be untouchable.
Right.
It's a paradigm shift, and it raises so many possibilities for the future of HIV treatment.
Yeah.
And for people living with HIV, it offers a glimmer of hope for a life free from the fear of HIV-related neurological complications.
So stay tuned, because in the next part of our deep dive, we're going to take a closer look at those broader implications. We'll explore what this research could mean for the future of HIV treatment, and what it could mean for you, our listeners, who are living with HIV and navigating the complexities of this virus every day. We'll be right back after a short break.
Okay.
We'll be right back.
Sounds good. Welcome back to the HIV RNA Test Guide podcast. Before the break, we were getting into the exciting details of BLZ-945 and its potential to eliminate HIV from the brain.
Yeah, it really seemed like a promising development.
Yes.
You mentioned a paradigm shift earlier. Can you explain what you mean by that? For our listeners who are used to the idea of viral suppression, this research is pointing towards something much bigger, isn't it?
It really is. For decades, the focus has been on achieving viral suppression with medication.
Right.
That's been the goal, to keep the virus under control, to prevent it from progressing to AIDS, and to stop transmission. But this research suggests that we might be able to go even further, to actually clear the virus from reservoirs in the body, starting with the brain.
So we're shifting from managing the virus to aiming for a cure. That's a huge change in perspective. Is that a realistic goal at this point?
It's definitely a goal that's now within reach. This research, along with other advancements in gene editing and immunotherapy, has given scientists renewed hope that a cure for HIV is possible. It's no longer a pipe dream.
That's incredibly encouraging for our listeners who are living with HIV and hoping for a future without this virus. But I imagine there are still some major obstacles on the road to a cure. What are some of the biggest challenges researchers will need to overcome?
One of the biggest challenges is the complexity of HIV itself.
Hmm.
The virus is incredibly adept at mutating and hiding in the body,
Right.
making it difficult to completely eliminate. It's like trying to track down a master of disguise who's always one step ahead.
So even if BLZ-945 is successful in clearing the virus from the brain, there might still be reservoirs of HIV lurking in other parts of the body.
That's a possibility. Researchers are still working to fully understand all the places where HIV can hide, and they're developing strategies to target those reservoirs as well.
So it's a complex battle, and we're still figuring out all the enemy's hiding places. What about access to these potential new treatments? Let's say a cure or a functional cure does become a reality. How do we make sure it reaches everyone who needs it?
That's a critical question. We need to ensure that these advancements are accessible to all, regardless of their location, socioeconomic status, or any other factors.
Right.
This requires collaboration among governments, healthcare providers, researchers, and advocacy groups to make these treatments affordable and available to everyone.
It's a reminder that scientific breakthroughs alone aren't enough. We need to address the social and economic barriers that can prevent people from accessing life-saving treatments.
Exactly. We need a multi-pronged approach to make sure everyone benefits from these advancements and that no one is left behind.
This research also brings up another important issue: the stigma that still surrounds HIV. If we reach a point where HIV can be cured or effectively eradicated from the brain, will that change the way people view the virus and those living with it? I'm thinking about our listeners who have faced discrimination and judgment because of their HIV status.
I certainly hope so. Stigma has been a major obstacle to HIV prevention, testing, and treatment for far too long.
Yeah.
It's fueled misinformation, fear, and discrimination.
Right.
And it's prevented people from getting the care they need.
So a cure or a functional cure could help to finally break down those harmful stereotypes and misconceptions.
It could be a powerful tool for changing hearts and minds. Imagine a world where HIV is no longer seen as a life-defining sentence,
Right.
but as a manageable condition, even a curable one.
Yeah.
That could have a profound impact on how people perceive the virus and those who live with it.
It's about reclaiming the narrative, shifting from fear and judgment to hope and understanding. This research gives us a chance to do just that. But it's important to acknowledge that even if we do find a cure for HIV, the stigma won't disappear overnight.
You're right. It will take ongoing education, open conversations, and a commitment to challenging those outdated beliefs.
So it's a process, and we all have a role to play in creating a more compassionate and informed society. But let's bring it back to the science for a moment. I'm curious to know more about how the study was actually conducted.
Sure.
Can you give our listeners a little behind-the-scenes peek?
Of course. The researchers used rhesus macaques,
Okay.
which are very similar to humans in terms of their immune systems. They divided the macaques into groups and gave them different doses of BLZ-955 or placebo for several weeks.
Okay.
Then they used sophisticated techniques to measure SIV levels in the brain, as well as the levels of macrophages and other immune cells.
I remember you mentioned that they were able to actually see where the virus was hiding in the brain. That's pretty incredible, isn't it?
It is. They used advanced imaging techniques to visualize and quantify the SIV RNA in different parts of the brain. This allowed them to see exactly where the virus was concentrated and how effectively BLZ-945 was reducing its levels.
So they weren't just looking at overall viral load. They were able to pinpoint the virus's location and track how BLZ-945 was working on a very precise level.
Exactly. That level of detail is remarkable, and it speaks to the rigor of this research. They weren't just looking for a general decrease in the virus.
Right.
They wanted to understand how BLZ-945 was working within the complex environment of the brain.
This is such a fascinating deep dive.
Yeah.
We've talked about the science, the potential for a cure, the challenge of stigma, and the importance of access to treatment. But we've also touched on some of the concerns about the long-term effects of reducing macrophages in the brain.
Yes. That's something that researchers are going to be monitoring closely as BLZ-945 moves into human trials.
Right.
They'll need to find that optimal dose, one that effectively targets the virus without causing any unintended consequences.
It's a balancing act, isn't it? We want to get rid of the virus, but we don't want to disrupt the delicate balance of the brain's immune system.
Precisely. And that's where careful dosing and long-term monitoring will be absolutely crucial.
This research feels like a turning point in the fight against HIV, particularly for those living with the virus who are concerned about its impact on the brain. but it's also important to keep things in perspective.
Absolutely. It's important to remember that BLZ-945 is not a cure for HIV.
Right.
It's a potential new tool, a promising lead that could significantly improve the lives of people living with HIV, especially when it comes to protecting the brain.
It's another piece of the puzzle. And while there's still a long road ahead, this research gives us a reason to be hopeful.
It does, and for those who are interested in learning more about the research and staying updated on its progress, I recommend checking out the full study published in the journal Brain.
Yep.
You can also find more information on the National Institute of Mental Health's website.
Okay.
They have an article that explains the research in a clear and accessible way.
We'll definitely include links to those resources in our show notes so you can dive in and explore the research further. And of course, we'll continue to keep you updated on BLZ-945 and other exciting developments in HIV research right here on the HIV RNA Test Guide podcast.
It's a fascinating time to be following HIV research. With advancements like BLZ-945, we're getting closer to a future where HIV is no longer the life-altering diagnosis it once was.
Well, we've covered a lot of ground today, from the intricate workings of BLZ-945 to the broader implications of this research for the future of HIV treatment. But we're not done yet.
Oh.
In our final segment, we're going to zoom out even further and explore some of the ethical and societal questions raised by this research. Stay tuned for more. Welcome back to the HIV RNA Test Guide podcast. We've been deep diving into this incredible research on BLZ-945, a potential treatment that could eliminate HIV from the brain. And now it's time to step back and look at some of the broader implications of this discovery. You know, this isn't just about science, it's about people's lives and about hope and shaping a future where HIV doesn't hold the same power as it does today.
You're absolutely right. This research has the potential to change everything, not just in the medical field, but in society as a whole.
Yeah.
If we can effectively treat HIV in the brain,
Right.
it raises some profound ethical and societal questions that we need to address head on.
Well, one of the questions that comes to mind is, if we're talking about a potential cure, what does that mean for people who've been living with HIV for years, maybe decades, who've built their lives around managing this virus?
It's a valid point, and it's something we need to be sensitive to. For many people living with HIV, their diagnosis has become a part of their identity, and they've developed incredible resilience and strength in navigating the challenges of this virus.
Right.
A cure could bring immense relief and joy, but it could also bring up complex emotions and require adjustments to one's sense of self.
It's a reminder that a cure, while a medical triumph, wouldn't erase the experiences and challenges that people with HIV have faced. It's important to acknowledge that history and to ensure that those voices and perspectives continue to be heard.
Absolutely. The HIV community has been at the forefront of advocating for research, treatment, and prevention, and their insights and lived experiences will be crucial as we navigate this new era of possibilities.
And as we move towards a potential cure, we can't forget about those who are still at risk of contracting HIV.
Right.
Prevention efforts remain as vital as ever.
Absolutely. A cure wouldn't mean the end of HIV.
Yes.
It would be an incredible tool, but we still need to focus on preventing new infections, ensuring access to testing and treatment,
Right.
and continuing to challenge the stigma that still surrounds this virus.
So it's a multifaceted approach, and it requires a commitment from individuals, communities, and governments to work together towards a future where HIV no longer poses a threat.
Exactly. A cure would be a monumental achievement, but it's just one piece of the puzzle. We need to address the social, economic, and cultural factors that contribute to the spread of HIV and the stigma that prevents people from seeking help.
It's about creating a world where everyone has the knowledge, resources, and support they need to protect themselves and their loved ones from HIV. It's about fostering empathy, understanding, and a sense of shared responsibility.
You've hit the nail on the head. It's not just about scientific breakthroughs. It's about creating a more just and equitable world where everyone has the opportunity to live a long, healthy, and fulfilling life, free from the burden of HIV.
And for our listeners who are tuning in, eager to learn more about this research and its potential impact, we encourage you to check out the resources we've mentioned, the full study in the journal Brain, and the article on the National Institute of Mental Health's website. We'll have links to those in our show notes.
Knowledge is power.
Absolutely.
And staying informed is essential, especially when it comes to your health. We'll continue to cover this research and other exciting developments in HIV treatment right here on the HIV RNA Test Guide podcast.
So until next time, stay curious, stay informed, and stay hopeful. This is a time of immense possibility in the fight against HIV, and we're all in this together.